guys. Chapter 5. We are continuing in our trig journey. Okay, we did our chapter 4 test, maybe a week or two ago? And that chapter 4 test, when we did that, everything having to do with the unit circle, with our trig functions, right? So, we took that break, we did a little bit of graphing. We're continuing with that trig journey. So, we're still going to be working with the unit circles, and all that entails. And we're going to start in lesson 5.1 by learning some trig identities. Okay? Some of these are things that as you go forward, just by nature of habit of using them so much, you'll end up with them memorized. And you'll want to have memorized because there are certain ones of these as you move forward into calculus classes that you'll need to know. Honestly, a couple of these you already know. And then there's others that we'll use on occasion. They're not ones that you'll memorize as much, but just kind of depends. So, as we just kind of talk about these, the first set are the reciprocal identities. Do you know those? Do those make sense to you as you look at them? For instance, if I say sine, what's the reciprocal of sine? Cosecant. So notice what it says. Cosecant is equal to 1 over sine, or sine is equal to 1 over cosecant. You already knew those were reciprocals, yes? We've been there, we've done that. That was chapter 4. This is just the identity that kind of puts it into writing. And we'll use these identities, because some of the things we're going to do is we're going to be using these identities to simplify expressions, to solve equations, and so they're going to help us. So when I say cosine, you know the reciprocal of cosine is secant. Thus, secant is 1 over cosine, or cosine is 1 over secant. And then, of course, tangent. Yeah, tangent has a reciprocal of cotangent. So you can either think cotangent in terms of 1 over tangent. Tangent is 1 over cotangent. Okay, so those are our reciprocal identities. We have the quotient identities. We've talked about this top one. I don't know if you remember it or not. Tangent is equal to sine over cosine. Do you remember talking about that? We talked about that tangent is y over x on the unit circle. And on the unit circle, we know an ordered pair is cosine comma sine. So thus, tangent is sine over cosine. Good one to know. If tangent is sine over cosine, what's that say about cotangent? Cotangent is cosine over sine. So those should be familiar with you. You're going to end up committing those to memory just out of habit and use. Okay? Now, these next three, Pythagorean identities, we will use a lot. Okay? I would venture to say the top one you'll have memorized just because we use it so much. Okay? The other two, they'll end up somewhat memorized. Okay? So these are Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. 1 plus tangent squared theta equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta. Okay, so again, I'll show you some ways to use those, but those will be very important. And those still can continue on into calculus, definitely. Okay, these bottom two are going to be two sets that you're not going to be as familiar with, but they're good to become familiar with. So first of all, we have cofunction identities. And if you kind of go through and look, cofunction identities kind of pair up sine with cosine, tangent and cotangent, and secant and cosecant. And the idea is, if this is written in radians, the sine of pi over 2 minus theta is equivalent to cosine theta. So this has to do with the fact that sine and cosine are just a phase shift different. Like if I graph sine and cosine on the same graph, they're doing the same thing, aren't they? They're just slightly offset from each other. And so these cofunctions have to do with that phase shift. Now, what is pi over 2? 90 degrees also, yes? So if it's written in radians, you're going to see pi over 2 minus theta in your parentheses. If it's written in degrees, remember that pi over 2 is 90 degrees. So these cofunction identities could also say the sine of 90 degrees minus theta equals cosine theta. Okay? And then we also have our even and odd identities. If you remember even and odd, we talk about whether things are symmetric. So if two things are even, they're symmetric across the, I don't know, do we remember this? This is asking a lot here. Two things are even, they're symmetric across the y-axis. If they're odd, they're symmetric across the origin. Good. Okay. Yeah, so that's what these have to do with. Sine and tangent, for instance, are not even. They are odd, but so the idea is sine of negative theta equals negative sine of theta. Tangent of negative theta equals negative tangent theta. Cosine is symmetric across the x, and so cosine of negative theta equals positive cosine theta. You'll notice the cotangent, secant, and cosecant do the same thing the reciprocals do. The idea here is when you have a negative variable inside the parentheses on a trig function, this tells you how it converts. Does it convert to a negative function or a positive function when we take that negative off there? Okay? I know, a lot of this is just a lot of information taken in, a lot of, doesn't mean a lot to you right now, but this is the page you're going to be flipping back to for the next couple of days as we work through lesson 5.1. Okay, bold point there. The idea with the identities is that trig functions can be replaced with other equations that they are equivalent to in order to simplify or solve. So, lesson 5.1, we're going to break it into, honestly, I have to be honest, it's probably going to take us about a week to get through lesson 5.1, just because we're going to spend a couple of days working on simplifying and solving, but then we also have to solve, or simplifying, but then we also have to solve equations. And so if it takes me like maybe 2 days to teach each lesson, again, we're going to end up on this stuff for probably about a week. Okay, so yeah, the idea is taking, when we start looking at things, what can we replace things with from our identity list? So, I suggest we look at example 1 and see if we can get some ideas going here. Example 1 is asking us to find sine of theta and cosine of theta, given that tangent of theta is 5 and cosine of theta is less than 0 by using the identities rather than reference triangles. Okay, so you could have done a similar problem to this back in chapter 4. In chapter 4, we would have set up our reference triangles and used things like SOHCAHTOA, right? Okay, so that still exists, but we're going to look at how we can use identities here. We know tangent, right? So we have to use some kind of identity from above where we can put in tangent, and it will help us find something like sine or cosine, or something that we can convert to sine or cosine. Okay? Thoughts on this? Now, Mallory, you just said quotient, right? We don't want to start with quotient here. And starting with quotient would be more along the idea, we will end up using quotient, or at least, well, and on these problems, there's not just necessarily one way to go. That's what you have to realize. One way to go, though, we will end up using quotient towards the end. But to use the quotient, you really need to be able to know 2 of those 3 things. Okay? And we don't know 2 of those 3 things. We only know the tangent, and we don't know sine and cosine. Okay? Okay, I do. I want to start with the Pythagorean identity. Which Pythagorean identity do we need to use? Or could we use? Okay, if we know tangent squared, we should use one that has tangent squared in it, yes? So I'm going to start, let's see. And I'm actually going to, will you guys throw a fit if I flip that around and say secant squared theta equals 1 plus tangent squared theta? Okay, so that is where did that come from? Pythagorean identity, right? I didn't do any magic. I just copied down a Pythagorean identity. What do we know that we can fill in here? We know tangent of theta is 5. Now, I don't know if we've talked about this or not. Do you guys understand what tangent squared theta means? The idea that you will often see places write tangent squared theta. Realize that is the same as doing tangent theta raised to the second. Okay, so that's a notation thing. More common is to write tangent squared theta, but what it's doing is it's saying, okay, take tangent theta and square it. So if we fill this in, what do we know? Secant squared theta is 1 plus, what do we fill in for tangent squared theta? Tangent theta is 5, so we're filling in 5 squared. And what is 1 plus 5 squared? Okay, so I've got secant squared theta is 26. How do I finish this part off? Yeah, it says secant squared theta equals 26. So think about, what if it said x squared equals 26? What would you do if it said x squared equals 26? You would take the square root, right? So what do you do if it says secant squared equals 26? Take the square root. So if I take the square root of secant squared theta is secant theta. What's the square root of 26? Okay, that's the answer I want, the square root of 26. When you take a square root in an equation setting, officially, you need to account for when you take the square root in an equation setting, you need to tag on a plus or minus there until you examine, is it positive, is it negative, or is it by chance both? Okay? With that in mind, which one is secant? Is secant theta equivalent to positive square root of 26 or negative square root of 26 based on the information given in the original problem? I'm hearing whispers. I'm not hearing them though, that's the problem. What are you guys saying? Negative? Why negative? Okay. Because of based on what quadrant we're in type thing? Is that what you're thinking there? Okay. What specifically tells me here in my directions though? Cosine theta is less than 0. What does that mean? That means cosine is negative. What do we know about secant and cosine? They're reciprocals, yes? Remember when we do all students take calculus, or however you remember it? We look at our cosine quadrant. And in our cosine quadrant, secant does the same thing cosine does, right? So if cosine is negative, then what's that going to say here? Secant is what? Negative. So I know that because of that, secant has to be negative square root of 26. Now, all of that work, have I found any of my answers yet? No, the direction said find sine and cosine. Where could I proceed since I know secant is the negative square root of 26? If we know secant, we know Cosine? Because secant and cosine are reciprocals, yes? Okay, so essentially I'm honestly fine if you just write what cosine is at this point. If I go up to my identities, if I want to pair this up with an identity, I'm talking about my reciprocal identities at this point, and the idea that cosine theta is equal to 1 over secant theta, right? That's another identity pulled from my list up top. So that means cosine theta is 1 over negative square root of 26. Good news, I'm boxing it, which means you don't have to worry about rationalizing. Okay. So that Pythagorean identity, there was a reason we found secant. Once you know secant, it's really easy to know cosine. Okay, so I was given tangent. I now know cosine. Technically, I know secant also. Options. And I'll say options because there are different directions we could go here. We need to find sine somehow. Okay. Quotient identity. Could that work? My personal opinion, that'd probably be the easiest way to go. Not saying it's the only way to go, though. Did anyone else have other ideas they were going to try? Is there another Pythagorean identity we could use? Yeah, sine squared plus cosine squared equals 1. We could use that also. Is one of these methods more right than the other? No. Okay. I don't have a preference. It's, as we go through this chapter, it comes down to what do you guys see? Everyone's going to see problems a little bit differently. So, personally, I like the idea of using a quotient. Which quotient should I use then? Yeah. Tangent of theta is equal to sine of theta over cosine of theta. Fill in what you know. So tangent is what? 5. And we have sine of theta divided by negative 1 over square root of 26, or negative of 1 over square root of 26. How do I find sine theta here? Multiply. If sine theta is divided by something, we want to multiply it to the other side. So then I have the fact that sine theta will be equal to 5 times whatever the negative 1 over square root of 26 is. How should I write that as a final answer? 5 times negative 1 over square root of 26. What'd you guys write? Or nothing because you're waiting on me to write something. What is 5 as a fraction? 5 over 1 times 1 over square root of 26. Tack on a negative, so negative of 5 over square root of 26. Based on the fact we left the other one with a radical in the denominator, you get to leave this one with a radical in the denominator. I don't know, did anyone try using the Pythagorean identity to finish this off? It works, it's doable. You have to be able to add and subtract fractions a little bit more in that situation, which is why I think this one's a little easier. Okay, so what you're seeing here is you're going to have to look at what's given and look for identities that pull those together that we could use. Questions? Okay, a problem like what we just did is going to focus on those top row identities, the reciprocal, the quotient, the Pythagoreans. The cofunction and even and odd identities will come up in specific situations, okay? And you'll be able to tell more when those come up, and I'll explain that here in a little bit. But Okay, let's try example 2 then. Given that cosine of theta is 34/100ths, find sine of theta minus pi over 2. Thoughts on what type of identities we're going to have to use here? I wouldn't say Pythagorean just because it's not just the sine theta that we're being asked to find. We're being asked to find sine theta of theta minus pi over 2. Where do you see that pi over 2 up above? The cofunctions, right? Now, what do you notice though? It's backwards to to what's given in the cofunction list, yes? So we're going to have to adjust a little bit, manipulate a little bit. But here's what I'm going to tell you. Anytime you see something that is theta minus pi over 2, pi over 2 minus theta, or theta minus 90, or 90 minus theta, in your parentheses there, go straight to your cofunction list. To me, like that's a big red waving flag at me saying, hey, I've got a 90 or pi over 2 being either minus or minus from. I'm going to look at my cofunctions. Okay? Now, a couple of different ways we can look at this. If I start with what is given, which is sine of theta minus pi over 2. I always struggle with which way I want to explain this one. So, first of all, what does that read when I flip my pieces in the parentheses? Okay, it's now sine of negative pi over 2 plus theta. So if you look up at your cofunction list, I'm at least in the right order now, right? I'm in the right order. Am I exactly there? What am I off by? If I'm comparing that I have negative pi over 2 plus theta, and these up here are pi over 2 minus theta. I'm off by a... What are my signs off by a negative? So what we want to do in this situation is let's think of it as like factoring out a negative. If we factor out a negative, what does this part become in the parentheses?
Why did we change it?
Like, why did I flip the order here?
Yeah.
Because I'm trying to get it to look like what's up in the cofunction identity. Saying theta minus pi over 2 is not the same as saying pi over 2 minus theta, because my signs are backwards. Okay, so that's what I'm trying to get you guys to. We need to get to the point where my signs are the same, so I know what's going on. Does that make sense?
Yeah.
Okay. Okay, so if I take essentially factor a negative out here, what that means is I'm going to factor a negative out. And when you factor a negative out, a negative pi over 2 becomes a positive pi over 2. A plus theta becomes a minus theta. Now, when we have a negative inside the parentheses there, technically if you look at your even and odd, that means we just put the negative out front. So now we've gone from sine of theta minus pi over 2 is now equal to the negative of sine of pi over 2 minus theta. What do you know about sine of pi over 2 minus theta from above in our list? It's equal to cosine, yes? So sine of pi over 2 minus theta, this right here, is equal to cosine. And what's out in front of this? A negative. So we're now at the point that sine of theta minus pi over 2, which is what we're trying to find, is equal to the negative of cosine. What were we provided? We're provided that cosine is positive 3400ths. So what's negative cosine? Negative 3400ths. It comes down to, if this had been sine of pi over 2 minus theta to begin with, and they're giving me cosine of theta is 0.34, we would have known sine of pi over 2 minus theta is also 0.34. Because we had the pieces backwards and the signs basically being off by a negative, it's now negative 0.34. Okay, you might work that through differently in your brain. I always struggle with how best to explain it and make the pieces connect. I don't know if I've done a good job on that one or not, but do we see a little bit of how I went there? Yes, I agree. Okay, I'm just not, it's one of those things. I feel like for the first time I kind of want to show you the ins and outs of it. I do agree that, oh, hey, this is backward, it's off by a negative, so cosine's now going to be negative, it's going to be equal to the negative of that. I do agree with that. Okay, trying to show you directly how it connects, so on this first one. And for if they throw a more difficult piece in at you. Okay, so there's a good example of when you would use cofunction identities. We talked a little bit about even and odd in there. And I think, yeah, we'll use more even and odd on the back here a little bit later on. But you guys ready to try example 3? You guys got to talk to me here, okay? They're asking me to find what? Secant and cotangent if sine of theta is negative 2/3 and tangent of theta is greater than 0. Okay, those marks are just me thinking out loud. I'm being asked to find secant and cotangent. I'm given those two pieces of information. Start figuring out what direction you think you might want to go. I'm looking at my previous notes to decide, there's not just one right direction, though. That's the thing. Any thoughts of directions you might want to go? Okay, a Pythagorean identity of some sort? What Pythagorean identity do you guys want to use? Okay, I just heard the middle and I heard the first one. I see points of both of them. Okay, if we use the first one, we know sine and we're finding cosine. Now, is cosine something specifically we're being asked to find? No, but if we know cosine, what will we know pretty easily? Secant. That's an option. Okay? I also heard the second one. No, wait, we couldn't use the second one right now, could we? Not the second one. We could use the... How would you feel if I said we could use the bottom one? 1 plus cotangent squared equals cosecant squared. Why am I saying we could use the bottom one? If we know sine, then we easily know cosecant. Okay? It's what does your brain see? Okay? So do you guys want me to start with the top one and go from there? Okay, let's do it. So I'm going to write down the fact that it is sine squared theta plus cosine squared theta equals 1. So we're going to fill in what? Sine. So I'm going to say negative 2/3 squared plus cosine squared theta equals 1. Are we okay with what I'm doing here? What's the next step? Negative 2/3 squared is 4/9 plus cosine squared theta equals 1. Now what? Subtract the 4/9. So cosine squared theta, what is 1 minus 4/9? 5/9. What do I do to find cosine? Okay, square root both sides. So the square root of cosine squared is cosine theta. Square root of 5/9. Okay, we could say square root of 5/9, but be smart about this. Square root of 5, do I know square root of 5? No, I like square root of 5 is good. Square root of 9, what do you know? That's 3. So I'm going to call this square root of 5 over 3. And what should we consider? Plus or minus. Now, we have to be able to decide, is cosine positive or is cosine negative? Why?
Because tangent is positive and sine is negative, so that makes sense.
Okay, I can go with that. Are you guys following? We already know that tangent's positive, because that says greater than 0. We already know that sine is negative. Yes? Now, think about your quadrants. If we go back to all students take calculus, we have one quadrant where everything's positive, yes? In the other quadrants of our basic 3, what happens? You have sine's the only thing positive, then tangent's the only thing positive, then cosine's the only thing positive. So, if we know tangent's positive and sine's negative, that means tangent has to be positive. Nobody else can be positive, correct? Sorry, I'm tying my words up. So, for that reason, I'm going to say that, whoops, let's put it right down here. Cosine theta is, what do we say? Negative square root of 5 over 3. Wasn't quite ready to go there. Okay? And again, that's because of, using that idea right there. Now, does this give me an answer? I mean, technically we weren't asked to find cosine, but yeah, reciprocal. So the idea that secant is 1 over cosine theta. So what's that mean? Secant is 1 over the negative square root of 5 over 3. What happens when you do 1 divided by a fraction? Flip that bottom fraction up. And so that means that secant theta is negative of 3 over square root of 5. Okay. Not quite done. I still need a cotangent. Okay. Could we do a quotient identity? I could do a quotient identity. Could we also still do a Pythagorean identity? Yeah. It's a personal call. What do you want to do? What's the preference there? Quotient? So since I'm being asked to find cotangent, the best thing to do would be to say Cotangent theta is cosine over sine. And I'm writing those out because I want people, when they look at my notes, to be able to see where things came from. So, start filling it in. Cotangent theta is equal to what over what? Okay. What was it? Okay. Negative square root of 5 over 3 divided by negative 2 over 3. How do we divide fractions? Multiply by the reciprocal. Keep change flip. So this is negative square root of 5 over 3 times negative 3 over 2. Which ends up giving me what? Square root of 5 over 2. Because 3's cancel, and negative times a negative is a positive. Now, here's kind of a self-check. Does it make sense that cotangent came out positive? Yes, because we were told in the beginning that tangent is positive, so by golly, cotangent better come out positive. If it didn't come out positive, I need to backtrack and see why. Did I mess up my sign elsewhere? Okay. I think that's going to have to be a good stopping point because otherwise I'm not going to get very far. If you flip over and look on the back, you'll notice we're going to start simplifying expressions tomorrow. Okay, there's a lot to, again, you have to look at the problem and kind of decide. You can start working on those odds a little bit. However, there's only the first handful that you can actually look at. So the 1 through 37 odds, as I said, we're going to take several days to work to get through this stuff. So it's all about using the identities, though.